Hey there, and welcome back to today's deep dive. Usually when you think of manufacturing, you picture,
Like sparks flying everywhere, deafening assembly lines.
right, exactly, just absolute sensory overload. That is the classic industrial age stereotype.
Oh, for sure.
But it is great to have you with us today because our mission is to unpack a completely different reality, which is the surprisingly fascinating world of absolute calculated precision.
It really is a whole different world.
It is. We are looking at advanced cutting solutions today, and we're going to explicitly focus on two massive stars of the show, the Velocity Flatbed model and the Velocity Template model.
Yeah, and these systems, I mean, they fundamentally reject that old chaotic stereotype. They completely replace all that chaos with just strict mechanical control.
Well, let's start by looking at how the Velocity Flatbed model handles the flexible side of things.
hmm
I mean, it's essentially the workhorse for apparel, footwear, and, furniture manufacturing.
Right. It's dealing with materials like dense industrial textiles, polyvinyl chloride or PVC, and really thick cardboard.
And the size of the workspaces on this thing, they're pretty massive, right?
Yeah, they scale up to 59 by 47 inches.
Wow.
But what's actually crucial here isn't just the sheer size, it's the universal knife design.
Meaning you don't have to keep swapping out parts.
Exactly. A single cutting head adapts to all those varying material densities without you having to constantly swap hardware.
That is super efficient, which brings us to the workflow, specifically that print then cut configuration.
Yeah, the print then cut.
So it annotates patterns with the pen tool, and then it cuts. But crucially, it operates strictly sequentially. Like, it never prints and cuts at the exact same time
Never. That isolation is very deliberate.
because of the vibration.
Right. If a machine attempts to print and cut simultaneously, the vibration from the blade, or even just tiny micro shifts in the textile, it inevitably throws off the alignment.
Ah, I see.
So by completely separating the actions, the system guarantees perfect registration accuracy. The blade lands exactly on the printed line every single time.
It's exactly like a master chef executing mise en
Oh,
place.
that's a great way to look at it.
Yeah. You meticulously measure, chop, and prep every ingredient before you ever even turn on the stove. You don't frantically chop onions while the garlic is actively burning in the pan.
No, that would be a disaster.
Right. The strict sequence is what eliminates the margin for error.
Exactly. Preparation, then execution.
But so if the primary enemy of flexible textiles is misalignment, the enemy of rigid substrates has to be movement.
Absolutely.
Because a chef's knife, or, a universal cutting head, that is not going to slice through solid acrylic.
No, it definitely won't. Which shifts the entire approach when we look at our second machine, the Velocity Template
It's
model.
a heavyweight champion.
Yes, this is built specifically for unyielding materials like
Right.
heavy cardboard and acrylic. And to penetrate those, it relies on a massive 24,000 RPM milling cutter.
Okay, wait. 24,000 RPM for a milling cutter sounds completely counterintuitive, though.
How do you mean?
Well, at that speed, aren't you just tearing the material apart? It sounds like applying a chainsaw to a scalpel's job.
I mean, yeah, it does sound violent.
Right.
But in the physics of milling, extreme rotational speed actually creates a much cleaner edge, provided the material is entirely immobilized.
Ah, okay.
This machine cleanly slices acrylic and PVC down to a thickness of 1 to 3 millimeters and craft paper down to 1/10 of a millimeter.
That is insanely thin.
It is. And to achieve that without shattering the material, it uses a heavily reinforced table with an industrial vacuum hold.
Oh, so the vacuum hold isn't just for, general stability.
Not at all.
It's literally the required counterforce to a 24,000 RPM blade. The extreme speed only works because the table's grip is equally extreme.
Spot
It
on.
locks down that millimeter-thin acrylic so it can't vibrate even a fraction of an inch.
Exactly. The immense speed of the cutter, perfectly opposed by the absolute stillness created by the vacuum, well, it results in clean part removal with zero deviations.
Wow. So taking a step back, both of these systems, the flatbed and the template models, are essentially optimizing productivity and eliminating waste, right?
Yeah, by pairing these specialized cutting physics with modern CAD, computer-aided design and seamless network connectivity.
They really demonstrate that high-level efficiency doesn't come from doing everything at once,
No, it comes from applying the right mechanism in a highly controlled environment with the right tool.
which leaves a fascinating concept to chew on as we wrap up today's deep dive. We just examined these state-of-the-art machines that achieve flawless, zero-error perfection, specifically by refusing to multitask.
Yeah, executing only one independent operation at a time.
Exactly. What does that mechanical reality tell you about your own human obsession with multitasking in your daily work? Maybe it's time to prep your ingredients before you turn on the stove. Catch you next time.